particularly on data. So data on soil, fertilizers, and on that side. Where do you think you have the data that is untapped? I think you are already doing a number of work with such data. So, but for everybody's interest and how it can be useful for the Sri Lankan context. One high impact gap Sri Lankan agriculture sector has, and that could be the gap could be solved or at least reduced. What that would be. The introduction is already done, and therefore we will straight away jump into a few critical questions and see from your perspective how you look at it. So keep your perspective, at the same time consider also Sri Lanka and what we can do to bring Sri Lanka or make Sri Lanka great again, right? Why not? Asita is thinking whether have you ever been great? Yes, we have been, right? That is what you are told, right? So yeah, so how do we make that happen is the discussion, and see how we'll do it. So I'll start the discussion with Tushar, and so you being now the in charge for our food and everything related, right? So the question is, in fact, like you in your keynote, you have highlighted a number of areas where the department is working on, the government is working on, the ministry is working on in different angles. So, but the question is, if I ask you, if we all ask you to identify just one high impact gap Sri Lankan agriculture sector has, and that could be the gap could be solved or at least reduced, what that would be? One gap.
Thank you. Actually, now we are in the era of the traditional agriculture, conventional agriculture. Now this is the transition period actually. That is why I told that Sri Lankan agriculture at a crossroad now. Now, issue is I would say that mechanization is the one of the gap. It is a huge gap, except rice sector. But in food agriculture, I am talking about, to mind you, say from the tea sector. But in the food sector, except rice, other areas are not that much mechanized. That's the issue. Why now the labor force, agriculture really needs labor. It is labor intensive, so the entrepreneurships. Therefore, now we are promoting the mechanization in the agriculture from farm to fork. Farm to fork, it is required. The value chains need to be mechanized, but I am not telling the high-end machines, but at least for the small devices should be introduced into especially in the vegetable sector, and also in the OFC sector, and also fruit sector. If you see in our fruit sector, most of the fruit trees still in the backyards, home gardens, majority of the fruits. But now the trend is there for the commercial orchards. But even we don't have anything to pick the mangoes. It is a simple gadget, but still we allow them to rotten in trees. Therefore, I feel that mechanization, but later on we can think of how AI can be integrated into the machines, that is something else, but at least we should have the that the physical labor must be converted to the machine labor. That is a must in these years to come.
Yeah, actually I like that answer because I asked you about AI, but then how do we do AI even before we can't just fix the simple things, right? So, that's very good answer, and I hope that makes sense. And that also, those who are in engineering and others should see how we have enough engineers around. We have to see how they can help solve this problem. Even in your keynote, you were mentioning about you're working with some engineers on work on that nature. So thank you for that. So the next thing is a bit on, I'm going to move on to the next panelist. I will ask Manju a question next, another one from the agriculture side. So from the industry standpoint, particularly on data, so data on soil, fertilizers, and on that side, where do you think you have the data that is untapped? I think you are already doing a number of work with such data, so but for everybody's interest and how it can be useful for in the Sri Lankan context, the data that we have in that sector.
Thank you for the very important question. So what I'm trying to tell, or what I'm trying to talk about right now today, all the exercises, data, everything which I'm going to express today is what we currently put on work. All the projects, all these data sets, all these exercises, everything is now practically in the field. So this is not a presentation based scenario, what I'm trying to tell you. If you take agriculture as a cascaded system, you start from soil, then the second main important thing is the inputs. So one of the most important area is to manage inputs in order to get the maximum out of it. The efficiency improvement part of it, whether it is water, whether it is agrochemicals, whether it is fertilizer. The most important thing is the input and the type of input, how to manage it in order to get the maximum out of whatever the inputs we apply into our entire agriculture cascade. So the untapped data sets, most important data sets and the most important attributes are still here and there scattered. It's the most important thing to get everything into one place and put them at work. The second part is the growth aspect of the plant. So the growth modeling, how to model the input-output relationship is extremely important, because here, not like in our, actually I wear two hats, by profession I'm an electronics engineer, so when it comes to input-output systems, most of the systems we are talking about in electronics, we can control the entire scenario, but here we are not in a position to control the entire scenario here because of the natural variations, like weather, like unexpected occurrences. So how to model it in order to get the maximum out of whatever we have input into the system is the other key factor. Again, data is important, the weather data, weather prediction data, yield prediction data, all this comes into the picture. And once we put all these things together, we end up with our result, which is the yield. Now, how to keep this yield at the lowest cost possible, how to reduce the cost of production of the farmer, how to maximize the profitability of the farmer for him to be in this game, not to go here and there and do some other businesses, but one of the most important things is that farmers are going away from farming, they are going for some other activities, so how to keep them. Then the economic data sets comes into the picture, and how to manipulate or how to use those data in order to maximize that part of it or minimize the cost is the other important thing. Then according to DG's just mentioned, it is farmer to fork, so garden to fork onto the table. So then the marketing part of it, sales, post-production, post-harvest protection, post-harvest handling, all this comes into the picture. So that is the cascade we are talking about, starting from the soil to the fork. So the data is available, what to do with it, how to use this data in order to take intelligent decisions, in order to reduce and in order to optimize whatever we have or whatever we require is the key factor here. So when it comes to agriculture, especially when it comes to real inputs, then the data, way of data collection, the equipment and the instrumentation of data collection is extremely important, whether it is IoT devices or whether it is conventional data sets, soil testing mechanisms, everything. When you have that data, then what to do next is the key factor where we really need AI tools to take these decisions. Right? Now, as Professor Ekal just mentioned, we have two sectors, two groups of people here. One is purely AI and computing fraternity and the agriculture fraternity. Now, the meeting point is the most important part of it. Right? How we give this data to the other fraternity in order to get it nicely analyzed. Based on these analytics, what are we going to do in the field is the key factor. It is going to be a complete cycle. Once a cycle is nicely covered or fulfilled, there will be all the other problems starting to get resolved. The yield increase, cost of production going down, waste reduction, and almost all the other factors will be getting into a place where we can observe and control. That is where the key factor is going to be.
Thank you, Benji. That's like a full picture of what's happening at different levels. But you also highlighted maybe certain industries who have the luxury of being in all those subfields have access to such data. But then when it comes to like a big field like agriculture, even it was already mentioned that most of the agriculture work, at least in fruits and certain areas, happen very fragmented. Right? So even you mentioned about fragmented data. Right? So even if it's a single institution, there could be a lot of different units, and a big department like agriculture would again have a lot of different departments, subunits and places. So data is all fragmented, and even within units it might be difficult to share them. So the question from an industry AI data expert is on that line. So can you break it down and explain how this whole process works so that everybody understand, okay, so yes, there is data, there are problems that we can solve, and if you can put them together nicely, it can be done. But we wanted to just break everything down into pieces and explain the pipeline.
Yeah. Okay. I'm fairly new to this domain, but correct me if I have mistakes in the domain itself. So I will talk more about the technology. So the way I see the entire end-to-end spectrum, at the lowest level you have farmers, and they have built, like for years, they have built their own culture, which is not probably reflected in the research culture. I mean, there could be, the research language, it's not about not understanding the farmer's work, but there are a lot of data, cultural data, how they express. So that understanding will be differ from the research person to the real farmer. And in between you have people like Govijana Seva, Samuddini Amaka, who will run the operation and could be a good communicator back and forth. And also at top level, there are very interesting engineering as well as agricultural research, which is targeted towards the yield and the better productivity of the overall agricultural system. That's where you talk about the predictions, AI models, and all this, right? And all these tools are there, it have been there, like AI for agriculture, that was there. AI for human interaction, that was there. But the new AI, how it bridge is, this AI will act more like a human, right? Suppose if I want to communicate with a farmer, then we have to build a kind of agent who can collect farmers' data and express it back to the Govijana Seva or the upper level stream or the policymakers. And also you need to have some agencies who can self-predict. I mean, so in the past era, so we have been developing AI products, so we have to be a real knowledge worker. Let me show you with a good example, so how this next generation of data flow will change. It's a conversation between me and AI tool, right? So, hi.
Hey, great to hear from you again. What's on your mind now?
Yes, so I am surrounded with some experts in agriculture domain, and so probably we can talk about one concept came around is growth modeling in agriculture. As a techie person, I don't have the knowledge for this, but suppose if I ask this expert to explain what is growth modeling and the semantics around it, would you be able to build an ontology on top of it?
Absolutely. If the expert explains the key concepts, relationships, and terms involved in growth modeling, like what factors influence plant growth, what stages of growth are modeled, and what data is used, I can help you structure that into an ontology. That would mean defining all those terms, how they link, and creating a framework for the data. So once they give us the details, I'm ready to guide you in building that structure.
What growth modeling is, if you can explain?
Yeah. Actually, now we have the crop data from beginning. Now we are targeting this data with the yield and yield component. Then what can you suggest for this one? We will be getting data from the seedlings to the up to the harvesting stage in the total yield plus yield component.
It sounds like you're building a full growth journey from seedling to harvest. What I'd suggest is modeling the key stages: seedling growth, vegetative phase, flowering, fruiting, and harvest. For each stage, think about what data you measure, like soil conditions, water, growth rate, and then link these to yield components, like size, weight, or number of fruits. You can structure an ontology around these stages and variables. That way, you'll have a clear framework for your data, making it easier to analyze patterns in yield.
Yeah, thank you very much. So since I want to continue the conversation, I will stop here. But you can also explain whether you can generate programs and prediction models around this. If I develop the ontology, like with better explanations, maybe it could be 2-3 hours of work, but still you can generate it, right?
Absolutely. Once you've structured the ontology with all those relationships and data points, it becomes the foundation. From there, I can help guide you in designing prediction models, whether that's yield forecasting, growth stage predictions, or optimizing inputs. With a solid ontology, we can identify which variables feed into what predictions, and from there, you can build or train models accordingly. It's definitely doable.
Thank you, thank you. And from the farmer's point of view, can you act like a farmer's mentor who will talk in farmer's language, and it has to be Sinhala? So if you can mimic the initial version.
මම ගොවි කෙනෙක්ට මේ කතා කරන්න ඔවුන්ගේ සරල දැනටමත් භාවිතා කරන පරිසරය ඇතුළත. අපේ වගාවට හොඳ කුකුර, ඊවැරදි ජලය සහ හොඳ කාලගුණය තිබාම අපිට හොඳ ආදායමක් ගන්න පුළුවන්. මේ
So I will stop there. But the beauty of this agency is ability to learn, just like us. Right? We learn skill on the fly, right? So when you go through lectures, sessions, so we learn. So likewise, any skill can be teach to these people. So they become a full skillful, similar to person. So it will not replace, but they will assist you. But you can think how deep this kind of agents can go, right? And this is the future. I mean, today we might talk about the generative AI, but in next generation of agriculture end-to-end workflow is more towards agents who will assist different parts of the chain, and they will auto-drive, they will think for us, and they will design the entire system for us. So this is how I see end-to-end workflow.
Okay. Yeah. So I thought Sautra will give some answers, but he was being lazy and asking his agent to do it. So, okay, which is better. So that's, yeah. So I was going to ask Sautra, like, do we still need to bring you next time, or shall I just call an agent and ask? But, I'll do that next time before I call him. Okay. So thank you, Samantha, for that. And in fact, like, yeah, so things have become so straightforward in terms of understanding and translating any workflow into automation and mechanism. Right? That's I think that is what we are trying to drive through, and that was very clear and nicely done. Let's now move on to Asita. Hi, Asita. You have anything to say now? Yeah. So yes, AI can do a lot of things, but still it can't bring all these people together here like this and put into working groups and make them to talk and do these things. So that I hope we still have to do. So from so if I'm talking to you from Learn's perspective, CTO Learn, and also all these projects that you are running related to AI and other initiatives towards national development. How do you see Learn and these sort of working groups can get involved, particularly in terms of data sharing that was mentioned, that like, so now we are two communities and then we don't share data, that was what was said, so that we can, if you share data, the rest of it can be done faster. And but obviously when you also want to share data and do these things, you might also need other things, collaboration, which we are doing, infrastructure that might be needed, some computing and other infrastructure. So how do you see we can put all these together for?
Yeah, I think in the question also you basically answered half of it, so yes, that's fine. It's easy, so right, fine. But yeah, I'll keep it short. So yes, from Learn's perspective, I think we already have the expertise and the credibility that is built over 30 plus years on providing trusted connectivity to the research and education academic community. So that is there, and we can build on that, and we are actually trying to build on that to connect more institutes and even probably schools and so on. So I mean, at the moment we have state universities, private universities, research institutes, ministries, UGC and other similar institutes connected. So the trusted connectivity that comes with it, right? So that's number one, as you also mentioned. And the second one is the services. Now, for example, it's not just an ISP. We provide a lot of services on top of that, which cater to this research and education community. So one of those things is what we call federated access. Now, federated access is something that you know, if you know what Learn Zoom is. Learn Zoom, you can connect from your own institute credentials. You can connect to anything in Sri Lanka. Actually, if you so this federated access is something that goes beyond Sri Lanka. For example, if you are connected to Learn, you can get the federated access, and then you have services like EduRoam, where you go to any country where they have implemented EduRoam, any university, any institute, they have implemented EduRoam. You can just go and connect to EduRoam using your local credentials, and you will have access. And you have resources available. For example, if you go to GEONT, which is the European Union NRED Consortium, you can go to community.geont.org, and there are a lot of working groups and other resources that are available, which are accessible through your federated login. So you can just give your, let's say if you're from University of Penang, you can just give your PDN username password, and you can just log into this joint resources that are available publicly and publicly in the sense for that community. And so this federated access and similar services that are offered. So we have the infrastructure and then we have the services we provide on top of that one. And we have also increasingly have developed capacity building programs and been doing capacity building, as Roshan again mentioned. We have been doing a lot of AI-related capacity building, not just in Sri Lanka, but across the region. We have been doing other similar technology-related capacity building as well. So these are the things that we have been doing, which we can, and we are planning to take up to support whatever nationally important endeavors. The next thing that we want to do actually with these working groups and with these kind of networking events, collaborations, is to bring the collaborations to the front. And as you know, as Kanaka was saying, you can have all the models, but the biggest problem in AI is the lack of data. And lack of data in the sense that at the moment, we are relying mostly on data that is produced elsewhere. Those are not Sri Lankan data. Those are staggered, clustered, not available, not maintained, right? Even like, lot of research that is being done, those are not maintained, throughout time. So like you'll do some research, you will publish, and that data is gone. Right? And you will do some research in Kandy, you will do some same research in Jaffna, same research in Gold. Nobody's connecting all this data together to come up with the national identification of these insights of this one, right? And it's gone. So without this one, the data that we are using, what Anna was doing, and I mean you can come up with a lot of things, but it is going to be biased towards without Sri Lankan data, and it's a problem. So all the predictions and all the things that will come, it will not have the real understanding of the ground situation in Sri Lanka. So first and foremost, we need to build this open and sharing data and collaborations across the country to solve nationally important problems. Right, so that is the collaboration platform that Learn can provide easily, because we already have that platform, right? The collaboration platform. And then the other one is actually we are also connected to all the NRENs and research networks across the globe. In the region, through APAN and Asia Connect project, we are connected to the Asia Pacific region, and through Asia Connect, we are connected to the rest of the world. So we can build collaborations across the regions, and through APAN, we can actually connect to other agriculture working groups in other countries. Agriculture working group in APAN, as I said, Project Talinda Bendergami is a co-chair of the agriculture working group, as well as the open and sharing data work group. So we can bring together these collaborations to actually bring meaningful AI models, data insights, and so on, and which will enable solutions that will have real impact. So that's what we can do, that's what we hope to do in the future.
Yeah, thank you, Asida. You said you will keep it short, and I was wondering whether it's going to happen, but yeah, thank you. Right, so in fact, okay, that's like the first round, and we are supposed to go to the second round, where we have a lot of time anyway. So, so the next round is going to be like right now. I think we set the foundation and go beyond now. So generally, not specifically in Sri Lanka, maybe I'll start from Samudra for this question. Not specifically from Sri Lanka, but in general, what is said is the new set of AI pilots, right? So most of these pilots fail, right? So most of these pilots fail, and there's only a very few, or I don't know, very few or nothing, very few that go through and become okay. Like at a pilot level, like for our research, for publishing papers, maybe writing and doing a prototype it works, but not in the bigger scale. So I'm going to start from you because you are in the field where you are building this. And also then I'll go to others who need such things, and also there are people who claim, like there are some who have already done and used and so on. So we'll start from you to, can you share some experience on this concept? I think it's a general one, not specifically agriculture, but yeah.
The noise to signal ratio in data was one of the key contributor for the classic AI systems, because you need a lot of effort to clean data and take a noise, remove the noise from data and take a proper signal. That cycle usually takes 6 months to 1 year, even 3 years in a classic data project, because a single human or team of human, they have to do it. But with agentic AI, now within maybe 1 hour, you can do the same work, the signal to noise ratio, and you can give up the project at the initial phase, because you find the weak points in data. In some data, you don't have actually the signal. So if you work a project with data which doesn't have any signals, it's pointless. That is how most of the AI projects failed in the past. And also, the second aspect is ability to tweak the algorithm. So to even high-end engineer to tweak an AI model, that requires massive effort, and it's subject to human errors, right? So you won't get a perfect AI algorithm as such from an average or high class, even, I mean, it doesn't matter whether you work for Google or he's subjected to human errors, right? But this agentic AI, they can comprehend to a level, because if you increase the compute and the knowledge structures, they can auto-discover most of the patterns and algorithmic context in the subject matter. So nowadays, to be honest, what I have seen is the success rates are more than even 60–70% in the modern AI projects. So we, as a practice, we spend initial period, maybe it's 1 or 2 days usually. So we decide whether to go or no go decision based on the signal to noise data. Say even if you find not much of a value in your data, by fixing the agentic flow, that means ability to communicate, the human skills and ability to detect problems, if you add more and more skills into agent, at least maybe 3–4 years down the line, we have a comprehensive agents who can take complex projects. So we don't think as like a failure, even if you have a failure. So even, I mean, if I take my childhood, so when you are building up, at the initial stages you fail. That is how you build up, right? So you feed back the failure into the model itself so that you grow. In the past, that was not the case, because getting that feedback cycle and running it 4,000 times, that's not an option. But if you do this agentic AI, so you can build an AI just like how we built a human. And they will actually perform, I mean, 10–20 times better than us, even in the top class. So I think that way we were able to tweak most of the failures. Now it's a matter of your tool experience. Do you have the correct set of tools? Are you adapting to the rate that AI is advancing? So those are the failures now. So how, I mean, I find it really difficult. Sometimes if I go on my annual leave and when I come back 2 weeks later, the AI I see is completely different from what I saw 2 weeks back. I'm talking about 2-week cycle. So that is the biggest challenge now we are facing. It's not about the accuracy or the failure ratio, but whether we can adapt to this rate. I mean, that's why even like if you take Microsoft and all these big giant companies, so they are laying off the people who cannot adapt, and that is the biggest challenge now. So that is how we have your
Yeah, that's from a technologist perspective, what you see. Yeah. And from an agriculture perspective, what maybe I can ask first from Manju. The question is this: the initiatives, most of them, at least from our industry perspective, they are still failing. Right? So yes, technology things are getting better, but it has to catch up and go to the industry. So from the industry perspective, how do you see?
I'll take two examples, which is in action now. One is in tea sector, as someone just mentioned. Now, we exactly do. I'll start from the way we have started the project. Now, TRI, Tea Research Institute of Sri Lanka, is 100 years old. We have one of the best knowledge sets of tea in that library. Now we are slowly converting this library into agentic AI model, right? So now the data is the real-time data I'm talking about. We fly drones with multispectral cameras, we collect multispectral data, we collect rainfall, we collect light radiation, we collect temperature. All these critical parameters are collected real-time, and we started converting the conventional and the real scientific knowledge archived from last 100 years slowly into agentic AI platform. Now once we input current data or the current data we captured with our own capturing systems, we are getting extremely good results now. As a very good example, the entire Uva province, the Uva region, hit a huge drought this year. We were running an agentic AI, even with the crop physiology data and the soil relationship data. So, I mean, since electronics people are here, we can simply model your entire soil system as a LCR network, right? So we model with our known languages. Okay, LCR networks are properly known. And in the other side, soil systems are properly known. Now these models are up. We collect data, put them into our conventional LCR models, put little bit of agentic knowledge we gathered, and now we are getting extremely good data or extremely good decisions from these data. If you get 50 millimeters of rain, this is going to be your soil wettability. With that soil wettability, with that temperature, this is going to be your evaporation rate. Then when exactly you should apply fertilizer into the soil. There is one. Now, if you take tea as an example, why I am trying to tell you all these things is basically we are talking about different levels. Very top level, very advanced level things which it is just discussed about. And what we have translated from that into our soil and our systems currently. There are both levels happening.
Because I have seen enough projects in research in the universities, in the engineering faculty. I have gone to force and in like agriculture faculty. And one of the questions that I have asked always is that what is the problem? Right? So you see solutions, and when you see solutions, most of the time, even now, when you say everybody wants to do some AI solution, when you ask what is the problem that you are trying to solve, is this a ground reality? Is this applicable to the farmer? Where are you getting this from? Did anybody tell you that this is a problem? And most of the time, I don't even get an answer. So it's good to see that with the way the industry is approaching is completely different, right? It's because it's a commercial problem, right? It has to have a market. But we have a very huge a set of brains and the knowledge and the capacity in the universities, academia, research, and I see this huge distance between the real problems and the need to go with the technology. So you're looking at the technology rather than the problem. And I don't know how true it is everywhere, but that is my experience. And if you look at, as I said, all these things that are started are failing. I think that is more relevant to academia and research probably, because that's why that Manu didn't even answer your question. He said, no, we are doing fine. Right? What are you talking about? Right? So probably this is coming from the research side or the academic side, where you see so many pilots not connected, even right from the department, like, collaborate, but, there are staggered research that is being done, not addressing ground level problems, more focused on the latest technology for publications or to get the new technology. That's it, right? But it's not phrased in maybe probably that what our DG said earlier. We came to talk here about AI. Everybody wants to integrate AI for agriculture, but the main problem is mechanization, not AI. Right? Now, I think that is I think what is missing. We are not addressing the ground realities, and that's why most of the things fail, because it doesn't translate to what the farmer needs.
Okay, that makes sense. So it should be so the industry is anyway looking at problem that they want to solve, and not what they can solve. They are not.
We don't have to take things which we can't
solve, can't do. So that's our territory. So I started receiving threats from the organizers to finish this soon. So let me just ask the last question, and then maybe one or two questions from the audience. So the last question is from each one of your domain, like the government, from the agriculture industry, from like a general and also infrastructure provider, what you can give as specific resources or commitments to this community, where these two communities coming together, they are trying to work together and solve these problems. What can you each give? So we'll start from government.
Actually, discuss about the data is the key issue for the AI generated system. Then what we can provide, we have a huge department with the 265 institutions, units, plus 12,000 employees. Then everybody is directly or indirectly responsible of the data generation on highly diversified system. But we can assure that data can be available to the centralized system for others to utilize. That is because why we are lag behind, but they are not willing to share the data. That is the huge drawback in the Sri Lankan scenario. If we are going to share data at the free of charge, at free of the cost or at the nominal rate, this AI systems or digitalization should be in some other place. That is what we can assure. Then, but we need the kind of the technical support, because we are new to this kind of the modern techniques, not like academia. They are fully engaged in specific subject. Even we don't have IT engineers. We have mechanical engineers here, civil engineers there, but we don't have the IT the base engineers. Then we don't have in the cadre also. Then in future, I ask our engineers to kindly bring mechanical engineer having the knowledge on IT. That is how we can fill in the gaps inside the department. Okay.
In fact, the benefit of being in a community like this is where we can work together, right? So that's yeah.
So one contribution I can make commitments on behalf of 99X, but I can be a good mentor for now. If you take any university today, they are running out of internships because so what we are trying to do is build more software engineers, but that will not happen. So that era is over. So if we can build these people into domains like agriculture, medical, and other different domains, so for them I can be a good mentor and I can build up some group who are sufficient in this technology. So that will open up some job market for them in different domains. So if you learn technology, I strongly believe you have to work on science in the future. The engineering, I think engineering is going to be automated largely. So science will pick up in the future. So if we can make these interns coming out from engineering, science and other universities and make them more scientists who can do grassroots level innovation, I think that is one area I can contribute, and I am also running many initiatives like that. Few in numbers, so I cannot scale it, but maybe each domain I can build up at least 2-3 years.
Yeah, we start small. Yeah, that's good.
Yeah.
Thank you. Thank you.
Okay, as usual, I have been working with Faculty of Agriculture from last 15-18 years. So what I can easily offer is the entire knowledge we have in this subject to the university and to the researchers of DOA. Because I know that there are a lot of limitations in the faculty as well as in the department. Now, since you asked that question, I'll have to expose my other operations as well. Now, so I run 3 major operations. One is we have 2 agriculture input manufacturing and operation companies. Brown's Agri Solution, we produce and we innovate new inputs, so we can offer the knowledge and the AI tools which we use for that. And we are the largest tea grower in the world currently. So the entire data sets and the AI tools which we use and which now in action for decision making can be shared with anyone. So I have a philosophy and a policy where knowledge has to disseminate without any boundaries, whether it is a private sector knowledge or, so most of the knowledge what we are talking about is IP protected, so we have no problem giving it to anyone to use. I can remember in one of the conferences, now Professor Mohoti is here, she was trying to develop something to automate the tea plucking. So AI algorithms and vision system algorithms can go immediately into those things. So we can attract, or we can simply accumulate all this knowledge and focus this knowledge into places where the reality is happening. Right. Now, as he said very correctly, we have scattered data, scattered work happening here and there. I personally know a lot of Morto students are now trying to get into agriculture related work because of AI, definitely because of that, because they have realized that they can solve national level problems with their knowledge. So likewise, if we can put things together, we can fund even. For these accumulating projects, we can fund, we can give whatever the knowledge we have, we can give whatever the models we are using currently, and as he correctly said, we can offer any amount of internships and research projects we will be sponsoring, and we can work together in these areas. Because I have experience with Chalinda and them from last 18 to 20 years. We have been doing this in the faculty. So it's a working model, and we can simply continue with them.
Thank you.
Yeah, so I think from Learn side, we can, as I said earlier, we'll bring the infrastructure, connectivity, the services, and also the collaborations between. But I think one of the things actually got me thinking, and with the previous ACCA, previously, Professor Lasit Gunawardhan asked a question. We need how to provide this sharing platform, right? Because one of the key things, how to bring the data together. And Professor Lasit asked earlier, can we provide a platform? So that kind of got me thinking, because the talk about developing one platform, one centralized platform is actually being discussed for a long time, has never happened, and I don't think it's going to happen either, because the problem of data ownership and all these things kind of come to the picture. But when I was earlier mentioning, giving the answer, actually the answer came to my mind as well. I was mentioning that with the federated model, right? With the federated model, we can bring all this data together, and we can connect all the institutes if they can keep their data, whatever the data that they want to and can give publicly, they can make it available to the community. Whatever data that they have sensitive information, they can anonymize, pseudo-anonymize and so on, and still make available, and they can keep the rest for whoever selected groups as well. But I think that's something that we can actually implement very quickly, because we can scale it, because there's no central provider. Nobody has concerns about data ownership and privacy and so on. And I think that's something that I think we should bring, very soon, and I think we will try. I mean, we have never thought about it actually until now, but looking forward to open and sharing data. I think that's one of the things that we can quickly bring in. Try and get everybody to contribute and share the data, so that we can have a national database that everybody can use. Anybody can contribute. I mean, there should be other things like, for example, genetics and so on. They have to submit their data, right? They can't publish without submitting their data, but maybe policies has to change, but we can try the platform.
Okay, thanks. In fact, I was also thinking about validated data that you mentioned. Good. So, any questions from the audience? Except for the question when we are going to finish. We are finishing. Any other questions from? So one thing that you can see, the two working groups who are sitting and working here, the people who you need are here. They are promising a lot. I hope you can make the best out of it. Yes, please. You can please share the mic. Okay.
Thank you for the panel discussion and the moderator and all panelists. I think we received really good information. And as a ground level person, and I like he suggests that our responsibility of the food of our DG in our agriculture department. As a ground level person, I have a question regarding the cost of our food. And is there any possibility, like when we compare like other countries, sometimes they are expensive than Europe and US. And the other question is the variability, the varieties. Like when we were small, we had like many varieties like banana and mangoes, all kinds. But now what we can see in the market, really few. It's just we are buying, not our favorite sometimes, not what we want. And the other thing is the quality. The quality, how we can trust our food. Like there are many things talking about like chemical usages and things, and how we can give the food like for our children, with the safety. And is there anything going on with that? Like AI and mechanization, everything really neat, I know, but as a question, the problems as a consumer, do we have anything regarding that?
Right, thank you for question. It is a general public, the concern, this one, yes. Now, cost of production, cost of cultivation directly relate with the, what is the cost component of this production cycle. One is the inputs. Most of the inputs are important. Now, fertilizer, the price became double, triple due to the just Middle East conflict. Similarly, we had similar situations. Bitter situation is past also. Then most of our agriculture, the inputs, fertilizer, pesticides, and some other the chemicals, they are being imported into the country. Therefore, we have to depend on this one. That is why the government is promoting in-house manufacturing of agriculture inputs. But it is now one industry now started producing single superphosphate. But some of the material, raw material, again being imported. Then now price is more or less locally produced itself. That the second is the level of production. They are kept, the level of production also matters. Second thing is labor. Labor is with compared to the regional labor prices, ours is the highest now, highest in the Southeast Asia. Third is the productivity. Actually, productivity, that is the only one the promising area we should address. We have to increase the productivity. That is one. Because the pathetic the policy decisions during the past, going to the switch on to the entire organic policy, the devastated agriculture sector in Sri Lanka. Now we are still catching this one. Then these are the few aspects, but don't worry about the meal. We are the country not much used the chemical fertilizer, chemical pesticides. If you search down the line, we are 2.5 the AI kilogram per hectare we are using. The Japan is using 17.5 kilogram per hectare. Korea is with 25.5. But we have to take care of the way of application and indiscriminate utilization of these things. Then we are in a safe side. If you the ROP check 1,500 samples in 2-3 years back, he found only 4 samples pesticide residues beyond the permitted level. Then we are in a safe side. Then don't worry about the output, whether it is very toxic. Yes.
So just to resolve something, that AI is not the AI we were talking about. There is the active ingredient, the AI.
I don't know what that is.
So, there is the active ingredient of different chemical inputs. Now, as he very correctly said, most important thing is the input use efficiency. When we apply something worth 100, how much plant can absorb, the rest we simply lose. That we should fine tune. For your example, when we apply urea onto soil, it is maximum 25 to 28% goes into the plant, the rest evaporates and goes away. So those kind of things now with new generation fertilizers and now new generation application techniques. In private sector as well as the Department of Agriculture, we are trying our level best to come with different types of solutions. That is number one. Number two, using AI tools, the real AI tools, to decide when to put, what amount to put, to maximize the use efficiency. It is happening in paddy sector now. So it will go into other crops as well. There is another scenario. I'll take 1 minute. Have you ever seen a fertilizer, say us selling fertilizer, to improve the quality of the product? We always try to improve the quantity of the product. We don't develop fertilizers or we don't develop any input to improve the quality of the product. It's a quality-quantity balance. Now we are trying to develop things. They are trying to develop inputs. Most of these inputs are non-imported inputs in order to improve the quality of the product. Right? Now when you go and taste the Anamadu 25 years ago, the taste is completely different to today. So how we are going to get that taste back again while having the same amount of produce or while having the same the yield? that is going to be something very important in the future. Like we are trying to do that. Quality versus quantity, and no one is saying, I mean, we are selling fertilizers. We are also responsible for that. We always focus on the quantity, not the quality. Now that balance should come into the picture. So those are the major areas. He told the rest, but the use efficiency improvement is the key.
Why can't we use that gap certification like this there, but I think the practice is not so popular?
No, yes, there is now we can take somebody to water, but he has to drink. That is the thing in the gap also. We are investing much for last 10 years to, okay, farmers, please go to the gap. But why they are not going to the gap? That is the volunteer, the standard. If it is the compulsory standard, they will go. If it is a volunteer standard, they won't go. Because they then, end of the day, they will see rupees and cents, whether we are getting much more money. Then actually we have a plan, then Cargill, skills, all those things, they will come up with their programs to have a gap certified products in your supermarket in the same rate, same price, but farmer will get the more benefits.
Thank you. So I think we'll wind up here. If not, I'll go. You'll talk about more AIs that I don't know of. Right, so already there's one. Thank you very much, the panel, for that wonderful session and all the inputs and the commitment, and also the participants for the good question and being a good participants. Thank you very much. Let me hand over.
Thank you. Thank you, sir. Now we have come to the end of the panel discussion on the theme from farm to algorithm, bridging agriculture and AI for national impact. Thank you to all our esteemed panel members for sharing their invaluable insights and also experiences during this engaging discussion. Thank you very much, sirs. Please remain on the stage. Next, as a gesture of our gratitude, we would now like to present